Hello everyone, welcome to the solar system training session. In this video, we will discuss about the solar system components. The main component of a solar system is a PV module. There are two types of PV module. Number one, a polycrystalline panel, and number two, a monocrystalline panel. To make the cells for monocrystalline panel, silicon is formed into bars and cut into wafers. As you can see a symmetrical picture on the right side of a screen. Whereas to make the cells for polycrystalline panels, fragments of silicon are melted together to form the wafers, which is clearly mentioned on the right side of the screen. There are some few comparison of a monocrystalline versus polycrystalline. The monocrystalline panel has a higher area efficiency as compared to the polycrystalline due to its material characteristic or formation characteristic. Number two, the temperature coefficient is much better in a polycrystalline panel as compared to polycrystalline. Third, we have the durability and performance. As the temperature coefficient is much better in monocrystalline, therefore the performance of the monocrystalline panel is higher as compared to polycrystalline. The cost of monocrystalline at early stages was higher as compared to poly, but now the market is adopting monocrystalline from the last few years. Therefore, the cost difference is shrinking and reducing day by day. There are some few advancement took place in the solar module construction. Some are listed as number one, the passivated emitter and rear cell, which is a PERC mono. Number two, the half cut, and three, the bifacial modules. Let's discuss one by one. Number one is a PERC. The PERC cell is integrated with the back surface passivation layer, that the reflection of the light from back layer helping to generate more energy as compared to the simple. It also reduces the electron recombination, which can cause to block the freely movement of the electrons. And lastly, it reduces the heat absorption, which can be caused by reflecting light above certain wavelength, which is 11A0 nanometer. Second we have is a half cut. As the name indicates, that the cell have been cut in half using a laser cutter, which leads to below advantages: 144 cells instead of 72 cells, and each cell generates half current and wired in such a way to provide the total current which will be equal to the standard cell. Due to this activity, the resistance is reduced to 1/4 due to the half current, whereas the performance of the half cut cell is increased in case of the shading. Bifacial, third one we have is a bifacial. Bifacial module produces solar energy from both sides of the panel, that is from front as long as the back side of the panel, which increases consequently 30% more production by keeping some design parameters in consideration. But due to the limited application, because it requires some certain design condition to get the maximum benefit from the bifacial module, which we will discuss in our later stage or in later videos. The weight of the modules increase in a bifacial as compared to the simple monofacial modules. As the bifacial module is different in nature, so therefore the cost is increased in bifacial module. Inverter, the very main component of the solar system, is inverter. Inverter is a component which converts the DC current into AC current, which will be used as to serve the load and our daily usage. There are two types of inverters: grid-tied inverter or on-grid inverters. In this type of inverter, the inverters are synced with grid and follow the grid voltage, frequency, and the phase sequence. Number two we have is hybrid inverter. Hybrid inverter has two main components: the inverter itself, which converts the DC power into AC power, and the second part is the charge controller, which is used to manage the battery, and that will charge the batteries from solar system and discharge when we need. There are two types of inverters, like central inverter and string inverter. There are some few pros and cons of a string inverter. Let's discuss one by one. The centralized or a central inverter has a centralized architecture, whereas the string inverter has a modular architecture. The central inverter requires a DC combiners to make the current voltage or ampere as per the requirement of the inverter, whereas a string inverter may only require the AC combiners because it is already a modular. It has already a modular architecture. Central inverter is physically larger, higher nominal power per unit, whereas the string inverter is smaller in size and have a lower nominal power per unit. Longer strings and generally higher voltages from 1000 to 1500 volt in central inverter, whereas a string inverter, it is generally a lower in voltages from 600 to 1500 volt. Generic and high level energy optimization in central inverter, whereas more granular energy optimization in string inverter. The central inverter has a single point of failure. Like if the central inverter gets faulty, the major portion of the solar plant will be shut down, whereas the string inverter has no single point of failure in overall system, so some power loss will be taken in consideration if a string goes down or if a string inverter goes down. Central inverter needs technical expertise for service and O&M, whereas string inverter is easier to service. Less expensive overall USD per watt, whereas the string inverter is higher in cost. But the string inverters are most suitable for commercial industrial scale projects due to its working and O&M consideration. There are some more major components which is used in the solar system, that is the solar structure. It is a very important component because it is used to install the solar panels on solar structure. Number two, we have inverters, cable trays, cables, and the switchgear. PV mounting structure. Let's discuss the PV mounting structure. So PV mounting structure is categorized into three parts: fixed mounting structure, single axis structure, and dual axis structure. Each of them has some few pros and cons. Let's discuss one by one. So fixed mounting structure, the production of the solar system will be lower as compared to the tracker, because the tracker system track the solar energy by the movement of the solar panel in accordance with the direction of the sunlight. Ground coverage ratio. The ground coverage ratio of fixed solar mounting structure is low as compared